Hello and welcome to Solved Papers channel. My name is Godfrey. In this video, I am solving topical questions of Group 2 of Cambridge AS Chemistry. This is a June 2019 exam series. I advise my students to go topical. This is the sure way of getting the contents of each topic and then attempting the topical questions that will be set over a period of years, 2019 backwards. This way, you're sure to master the topic. Any question in the future exams that is set on the same topic, you are sure to know how to tackle it effectively. And this is a good way of, this is one way of the ways that you should be going if you want to score your an outstanding grade like A star or even A. If you have not subscribed to my channel already, please subscribe and share with your friends. Be sure to hit the bell icon. This way you will be notified every time I upload a new video. Let's get started. In every number, you'll find this writing here. I always explain that this means paper 2.1 of May, June 2019, number 1 is where this question appeared. And if you need to refer, you can be using this to locate the question in the past paper, and also if you need to take a peek in the marking scheme. Though I always encourage marking schemes are meant for markers, not for students. Alright, you can get this and more topical questions from this site, solvedpapers.co.uk, and it's good that you practice working out these questions yourself. That way you will internalize this topic and you'll be set for the coming exams. Numbers 1. Group 2 elements share common chemical properties. They share common chemical properties. Part 1, that is group 2 elements. Part 1, calcium reacts in cold water more quickly than magnesium because more energy is required to remove the outer electrons in magnesium. This occurs even though calcium atoms have a greater nuclear charge. Explain why more energy is required to remove the outer electrons in magnesium than in carbon. Of course, calcium and magnesium are in the same group, group 2. Calcium is below group 2, so it means it is below magnesium, so it means that it has got more energy levels. Therefore, magnesium has one electron shell less than calcium, so let's shield the effects of the outer electrons in magnesium. Thus its electrons are strongly attracted to the nucleus. So you would write that magnesium has one electron shell less, less than calcium. So means calcium has got more electron shell than calcium. So there is less shielding effect in magnesium to the outer electrons, so they are strongly attracted. So they are strongly attracted to the nucleus. They are strongly attracted by the nucleus. So you need more energy to remove an electron in magnesium than you need to remove in calcium. On part 2, 0.001 mole of strontium reacts with an excess of cold water. When the reaction is complete, a colorless solution is seen. Construct the equation for the reaction of strontium with cold water. Include the state symbols, because strontium is Sr. It's usually solid. It is reactive with water. Okay, water is a liquid. And what you get is strontium hydroxide, right? Which is aqueous, and hydrogen gas. So the equation is balanced. Part 3, 0.005 of calcium and 0.005 moles of strontium are added separately to 2 beakers. Each beaker contains 100 centimeters cubed of cold water. At the end of each reaction, a white solid and a colorless solution are seen in both beakers. Predict which element, calcium or strontium, produces the more alkaline solution. Explain your answer. Of course, it's going to be strontium. Strontium is more soluble than calcium. That is, the hydroxide of strontium is more soluble than that of calcium, so it forms a stronger base. It's more alkaline, stronger base, and this is because it dissociates more readily to give more OH. So your answer here is strontium forms a more soluble. Strontium forms a more soluble hydroxide, more soluble hydroxide. Strontium hydroxide is a stronger base, because you're saying more soluble, more alkaline solution. Is a stronger base. Since it can undergo dissociation, it dissociates more readily. To give the OH ion, or to give more. Let me use that, to give more OH ions. Very well. Part 4, describe one observation when magnesium carbonate is added to excess dilute sulfuric acid. Of course, when magnesium reacts with an acid, magnesium carbonate, reacting with sulfuric acid, this will give magnesium sulfate, okay, which is soluble, and carbon dioxide gas will be produced, and we'll also have water. So this gas called carbon dioxide will be seen as bubbles. So we will say effervescence, or bubbles if you want to be effervescence is seen, or in short, bubbles are seen, okay, of CO2 gas. Okay, then of course the white solid, magnesium carbonate is a white solid. The white solid, magnesium carbonate, disappears. the white solid magnesium carbonate disappears. So that's what is seen. Describe one observation. You can either go for effervescence or white solid. Those are two observations I've given you there. Part B, element X is a metal. X is a metal. X reacts with oxygen to form a black solid oxide. The oxidation states of X in this oxide is +2. The carbonate of X, this is a green solid. It decomposes on heating to form oxide and a colorless gas. Okay, that is a whole lot of information there. So we are told X oxide is black, but carbonate of X is green. Alright, and when you heat the green, decomposes. So this, when it's heat, right there, when we heat, we use triangle for heat, then it decomposes. Of course, it should give an oxide plus a gas, and the gas in this case, I guess, should be carbon dioxide. Okay, green decomposes on heating to form an oxide, which is this one here, and a colorless gas. That colored gas should be carbon dioxide. From the information given, state two similarities and one difference. Two similarities and one difference of metal X and its compounds, of with group 2 metals and their compounds. So we are told that the oxide, X in the oxide has got +2, so that should be in group 2. So X and group 2 of same oxidation, of same oxidation state, which is +2. That is a similarity. Another similarity is that the carbonate of X and group 2 carbonates decompose on heating. That's another similarity. Decomposes on heating. Now, what is the difference here? The carbonate of X is colored, while the carbonate of group 2 is not colored. You can see we are told the carbonate of X is green. So the carbonate of X, so I can just basically write that X, the carbonate of X is green, while carbonates of group 2 are white. Of group 2 metals are white. Very good. Write the formula of the oxide of X. Of course, you know that we are told that X has got oxidation number +2, and oxygen, we know that it has oxidation number of -2. Of course, you can ignore the minuses and the pluses, and then write 2 on this. Then you cross multiply. So what you get is X2, oxygen 2, which should give you XO. XO. That is the oxide of X. Write an equation for the reaction of this when it's heated. Of course, I'd written that up there. So you can write it again there. Of course, when you heat it, I'll use the triangle here again to represent heat. you'd get an oxide plus carbon dioxide gas right there. So this is an oxide, and this is the colorless gas. Carbon dioxide is colorless. Okay. Question 2. Question 2 is from paper 2-3, and this was question number 3. Okay. Magnesium reacts with oxygen to form magnesium oxide, obviously. State 2 observation that would be made when magnesium is heated strongly and placed in a gas jar of pure oxygen. Of course, magnesium burns with a white dazzling flame. So what would be observed? 2 observation that would be observed. Magnesium burns with a white dazzling flame. Magnesium burns with white dazzling flame, a flame that you cannot look at straight. Then once that is finished, white ash remains. Once the reaction is complete, there will be remaining of some white ash. B. Acid indigestion is caused by an excess of hydrochloric acid in the stomach. Magnesium oxide is commonly found in indigestion tablets. Right? Give the equation to show magnesium oxide relieves indigestion. So basically it's magnesium oxide reacting with hydrochloric acid. So magnesium oxide will react with HCl, and what we get is magnesium chloride, which is soluble, plus water. This is a base and this is an acid, so this is a neutralization. Of course, it will be kind of a neutralizing reaction, although the base is insoluble. This is in solid form, so you can give the state solid. This is aqueous, and this is aqueous. This is liquid. Name the time of reaction that occurs. Okay. This is a base acid reaction, so it is a neutralization reaction. C. Magnesium oxide is described as a ceramic material. Magnesium oxide is described as a ceramic material. It has a high melting point, very high melting point. State and explain. 2 answers required here. Why ceramic materials such as magnesium have high melting point? Of course, one is that they have giant structure. They have giant structure. They have a giant structure, meaning it has got extensive bonding, and to break all those bonds, which of course magnesium oxide is ionic bond, is going to need a lot of energy. Bond breaking is energy consuming. Bond making is energy giving. So lots of energy is needed. Don't forget, magnesium oxide is an ionic compound. Ionic compounds have got high melting point. Is needed to break the strong ionic bonds. Very well. Part D. Magnesium oxide can be made from magnesium carbonate in a one-step reaction using heat. Write an equation for this reaction. Include state symbols. So magnesium will decompose. Magnesium carbonate will decompose when heated. Okay, you don't have to include that, but let me just include that. Magnesium carbonate is solid. So when heated, it will decompose to magnesium oxide, which is solid, and carbon dioxide will be formed as well. Name the type of reaction occurring during this process. This is called a thermal decomposition. Using heat to initiate a reaction, which will result into two different products. So that's it, guys. Share this video with your colleagues if you find it useful to you, and you can add to soft papers to get this kind of and more topical questions for AS and other subjects as well. Thanks a lot for keeping company. I hope I'll see you next in my other video. Cheers and bye.